Hey guys, welcome back. This is the study guide video for chapter 2. I decided that on this test there would not be anything from 2.4, so we're only covering 2.1, 2.2, and 2.3, which means 4 of the 7 questions on this particular study guide you should be very, very familiar with because they are very, very similar to the quiz you just took on 2.1 and 2.2. Questions 5, 6, and 7 are from 2.3. Okay, so let's go ahead and begin. For number 1, oh, by the way, if you need a copy of this, go to Schoology, go to Class Notes and Materials folder. Within that folder, there's a folder called Chapter 2, Quadratic Functions. And within that folder, there's another folder called Study Guides for Quizzes and Tests. And inside of that folder, you will find the Chapter 2 Test Study Guide that looks just like this. You can go ahead and print that out for yourself. I will not be printing copies of this, okay? So it is there. You can print it on your own. Let's take a look at number 1. So we have describe the transformation of f of x equals x squared represented by g of x equals negative 3x plus 2 squared minus 1. So your first thing you're going to do, just like in the quiz, tell me the transformation or transformations, and there are more than one here. And then after you do that, graph each function. So there should be 2 functions, both on the same graph. All right, so let's see. Let me look at the transformations, and again, we're going to list the transformations in whatever order we like. No, I don't care which order they are in. So the minus in the front, that's going to be a reflection over the x-axis because it's happening outside the function. The 3 out here, that is a vertical stretch by 3. It's a stretch because 3 is greater than 1, and it's vertical because again it is happening outside the function. In here we have plus 2. That is 2 units to the left. Remember, it's counterintuitive to what you would think, but when you have an x plus 2 inside a function, you are actually moving the function to the left by 2 units. And then we have a minus 1 outside the function, which is 1 unit down. Okay, so we're going to graph now both of our functions, and this is super simple. The first function we're going to graph is the parent, f of x equals x squared, which you should be able to do in your sleep by now. 0, 0, 1, 1, 2, 1, 2, 3, 4, and then the reflection over on the other side. And connect your dots. Please make sure this is a curvy function. Everything in chapter 2 is quadratic. There should not be any pointy, absolute value-like looking functions. Alright, this happens to be in vertex form, so it's really easy to spot the vertex. The vertex is at negative 2, comma, negative 1. So negative 1, negative 2, negative 1. And we can see by the minus that this is going to open down and that there is some sort of a vertical stretch, so it's going to go down really quickly. I'm going to go ahead and just do a very small table. Again, my vertex is at negative 2, negative 1, so I'll pick a point smaller than negative 2 and one larger than negative 2, and that's fine. I don't really need a whole lot of points. So let's plug in a negative 3. Negative 3 plus 2, that's going to be negative 1. Negative 1 squared is positive 1. 1 times negative 3 is negative 3. Negative 3 minus 1 is negative 4. That means at negative 1, we're also going to get negative 4. But if you don't believe me, negative 1 plus 2, that's positive 1. 1 squared is 1. Negative 3 times 1 is negative 3. Negative 3 minus 1, negative 4. So at negative 1, we're down to 1, 2, 3, 4. And at negative 3, we're also down to 1, 2, 3, 4. I don't really care about anything else. I don't care about the y-intercepts or anything. Just go ahead and give me that. That would be fine for now. Okay? So that is number 1. Number 2. In fact, if you, now that I mentioned the y-intercept, if you did want to find the y-intercept, remember, you would have to let x be 0. So this would give you 4 times negative 3, that's negative 12 minus 1. It would be way down here somewhere at negative 13 is where this thing would eventually cross over. But like I said, I'm not asking you for it. That looks terrible. Sorry about that, guys. But it would be way down here. But again, you don't need to worry about that. Okay? Good. Moving on. Number 2. Find the vertex and the axis of symmetry. Symmetry. Am I writing that right? Nope. Of f of x equals 3 times x minus 1 squared minus 4. All right. So again, this is in vertex form. So the vertex is just screaming at you 1 comma negative 4. So super simple. And your axis of symmetry, x equals 1. Please do not lose points by not putting the x equals. That's going to make you very sad and me very sad. So don't do that. All right? Remember, axis of symmetry is always a line. Okay. Number 3. All right. Here we go. We have f of x equals negative 4x squared plus 8x plus 2. We're going to graph it. Again, this is coming straight from that quiz you had. You're going to find axis of symmetry. You're going to find the vertex. You're going to determine whether it's a max or a min, and the y-intercept. All right, so this is in standard form. When you have it in standard form, this a is negative 4, b is 8, c is 2. The axis of symmetry is found x equals negative b over 2a. So x equals negative 8 over 2 times negative 4. That's negative 8 over negative 8, which is 1. So the axis of symmetry is x equals 1. Very important. Make sure you write x equals. The vertex, therefore, is going to have the same, for the x-coordinate, it's going to be the same value as the axis of symmetry. Since the vertex is on the axis of symmetry, the vertex has to have an x-coordinate of 1. We're going to plug it in here, and we have 1 squared plus 8 times 1 plus 2. Order of operations, 1 squared is 1, 1 times negative 4 plus 8 plus 2, negative 4 plus 8 is 4, 4 plus 2 is 6. So my vertex is at 1, 6. This function has a minus in front of it. That means it is opening down. And if it opens down, it has a maximum. And the y-intercept is this constant right here. So there's a y-intercept at 2, or you can also say at the point 0, 2, however you want to write that. And finally, we're going to graph this. So we have a vertex at 1, 1, 2, 3, 4, 5, 6. You have your axis of symmetry at x equals 1. You have a y-intercept at 0, 1, 2. So that means there's a matching one over there. And really, we don't need anything else. We can just connect our dots, and we're good to go. All right. Number 4. For this one, we're going to have the function f of x equals x plus 1, x minus 7. This one is given to us in x-intercept form. And once again, for this one, you want the x-intercepts. You want the axis of symmetry, the vertex, the max, the min. Okay? So we can just see the x-intercepts. They're going to be at -1 and +7. So, oh, that didn't come out right. Sorry, just make the line thicker. That's how we fix it. -1 and at 1, 2, 3, 4, 5, 6, 7. Those are the x-intercepts. To find the axis of symmetry, we really want the midpoint between these 2 points. So the axis of symmetry is equal to -1 plus 7 divided by 2. Remember, p plus q over 2. And that's going to give me 6 over 2, which is 3. So axis of symmetry is the line x equals 3. 1, 2, 3. And that makes sense. That seems to be halfway between those 2 points. So that means my vertex is at 3 comma something, because the vertex is always on the axis of symmetry. We're going to plug in a 3. This will be 3 plus 1 and 3 minus 7. 3 plus 1 is 4, and 3 minus 7 is -4, and 4 times -4 is -16. Wow. Okay. All right. So what I'm going to do, because I don't really want to take this forever, I'm going to count these by 2, -2, -4, 6, -8, -10, 12, 14, and 16. All right, make that a little bit easier for ourselves. If not, it's going to be way down there. And connect the dots. Please remember to make it curvy, not pointy, but just curvy. We have the vertex. This is opening up, so this is a minimum. And that is that for number 4. Okay. Number 5. Let's take a look at the question. Write a quadratic function in standard form containing the point -6, -16, and x-intercepts at -8 and 2. Well, we got to start with x-intercept form before we make it to standard form, because they're giving us the x-intercepts. So x-intercept form, like I just did over here, looks like that, except there's an a in front. So x-intercept form looks like this. F of x equals a, x minus p, x minus q, where p and q are your x-intercepts. So this is going to be x minus 8, which is going to be x plus 8, and x minus 2. If this is p and this is Q. And it doesn't matter, you can switch them around, just make sure you put the right one where it goes. Alright, so now we have this. We need to figure out what A is. In order to figure out what A is, we're going to use that random point that they gave us of -6, -16. Remember, this is your x, and this is your f of x, right? So wherever there's an f of x, I'm going to put a -16. I have my A. Wherever there's an x, I'm going to put a -6. And again, -6. So I'm solving for A. This is going to give me -16 equals, this is going to be A times, that's 2, and -8. So -16 equals -16A, right? -8 times 2 is -16. Divide both sides by -16, so A is a +1. Alright, I'm going to continue that right over here. Since we now know what A is, we just go right back up here, and for A you're going to put a +1. Now the nice thing about having a 1 here is that it doesn't do anything, right? If you multiply anything, whatever this is, by 1, you're just going to get the same answer. So really, we normally don't put that 1, so we only have f of x equals x plus 8, x minus 2. But we want it in standard form. This is not in standard form. In order for it to be in standard form, we need to FOIL it. So x squared minus 2x plus 8x minus 16. And that is going to give me x squared plus 6x minus 16. And now you are finished. All right. Let's take a look at number 6. Number 6, they give it to you in a graph. And I know it's hard to see, but the x-intercepts are at -4, -4, and -0.5. So once again, you're going to do exactly the same thing that we just did. We have the two x-intercepts. So f of x equals a times x plus 4 and x plus 0.5, right? I'm going to take the opposite of that, goes in here. We need to figure out what A is, and that's where this point is going to help us. That's going to be our random point at 0, 4. So remember, this is x and this is f of x. So for f of x, I'm going to put a 4, and x is going to be 0. So 0 plus 4, 0 plus 0.5. All right, 4 equals is going to be a 4 times 0.5. Well, 4 times 0.5, that's just 2. 4 times a half. So this is just 2a equals 4. That means a equals, dividing by 2, a is 2. All right. And now we take this value and put it back up here, but I don't have any more space, so I got to come right down here. So f of x equals the a, which is 2, x plus 4, x plus 0.5. And remember, they want this in standard form, so we're going to need to FOIL this. Make sure you put that 2 out there, because you're going to need to distribute that at the end. So x times x is x squared, and then we have 0.5x, we have 4x, and we have 2. And that's going to be x squared plus 4.5x plus 2. And then we're going to multiply each term by 2. We're going to distribute by 2. So this is going to be 2x squared plus 4.5 times 2, that's 9x. and plus 4. And that is your answer right there. 2x squared plus 9x plus 4. All right, so easy enough. Let's move on to number 7, which is also the last problem. And here, this table represents a quadratic function. Write the equation of the function again in standard form. Just ignore this. On the original test, there was a number 8. So when you get number 8, I'm just going to ask you to cross it out. We're not doing any of that. Okay, looking at this table, we see these 2 points that are 0 at y values. These are x-intercepts, right? We know that x-intercepts are the x values that when you plug them into the equation, make the equation 0. So these are my x-intercepts. So I have x-intercepts at -9 and -3. So again, very similar to what we just did. F of x equals a times, this is x plus 9, x plus 3, right? We take the opposite of what we see there. And once again, we need to figure out what a is. You're going to have to pick a random point. It does not matter which one you want. Whichever one you pick, it's your choice. I'm going to pick this one just because I prefer to deal with a -5 than a -7. It just seems a little easier. So f of x is 8 and x is -5. So f of x is 8 and x is -5. Alright, this is going to give me 8 equals a 9 minus 5, that's 4, -5 plus 3, that's -2, this is -8a, this is 8, divide both sides by -8, a is -1. So now you take this value back up here, but we're going to move it over to the side, and wherever there's an a, you're going to put a -1. So f of x equals negative, you can put a -1 times x plus 9, x plus 3. Now this one we do have to multiply out, but please make sure you group these two guys together because we're going to need to distribute that -1 eventually. We're going to FOIL here. X squared plus 3x plus 9x plus 27. We're going to simplify what's in here. X squared plus 12x plus 27. And now we're going to distribute the -1 with each term. That's -x squared minus 12x minus 27. And now you are done. And that is the end of the study guide for Chapter 2. See you next time.